In our previous video, we showed how to do the data here for assignment 3 in SPSS. We did the t-test and we did the ANOVA, but it says to do it both in SPSS and Excel. So this video will show you how to do both types of t-tests in Excel. And so if you remember, number 1 was a dependent t-test, and it was looking at significant differences regardless of diet or age group. And the other one, since it says just group 1, we specifically want diet 1 versus diet 3 here. So those are the things. We can't answer number 3 in Excel. We could, but that's above your pay grade, and we would spend way too much time setting up whole tables and actually doing an ANOVA by hand to show you. So we're not going to do that one here. All right, so the data that you were given for in the sample ones here was in the SPSS actually, and not Excel to start. So what I'm going to do here is copy it over. There's a couple ways to do it. I can export it to an Excel sheet, okay, where I can show it here, export to database, or the easiest way really usually is just just highlight it all. You know, I can right click and copy, or I can just hit Control C and copy, which is what I do just because it's easier. I can use both hands. Then I'm going to go to Excel. All right. I'm not going to do it on the top line. I'm going to do it on the second line. And then I'm going to post in the data. And the reason I do it on the second row is because I need to put in the titles again. And so I have to remember the titles. Let's go back here. Diet, age, loss 1, loss 2, loss 3. There we go. So again, diet, age, group, loss 1, loss 2, and kind of a fun thing to help speeding up titles, though I could probably type it just as fast. There we go. All right. Now, just because I also like graphing things just to show, I'm going to do the first one as a graph, and then we're going to then do the calculations. But it's always good to be able to visualize things both ways. So I'm going to basically just do time point 1, time point 2, mean loss, and then standard deviation, just like we did last time. And I can then just use my simple equals average, Control Shift down arrow, and that one's in, STDEV, Control Shift down arrow, got that one in. Whoops, did something wrong. See if it likes me yet. All right, we're going to just retype that one in. There, somehow there was an error in there. Okay, so notice that even we have fun doing this stuff. Time point 2. Boom. So again, if you just remember, I'm doing Control Shift and down arrows and up arrows to get my values. So if I just look at this graph, insert, bar graph, all right, and then if I want to add my error bars, I'm going to design, add chart element, error bars, more error bars, only in the plus direction, cap it, and then I'm going to specify the value, and the values are going to be my standard deviations, which I highlight there. Okay, and close this. And so visualizing it looks like we lost a lot more at time point 1 than time point 2. But we don't know if this is statistically significant or whether it just appears to be that way. So we're going to do this. Now again, this would be a t-test. So to perform this, I'm going to do a t-test. And to do that here, I'm going to just type equals t-test Notice it says array 1. So array 1 is my first group. So I'm going to highlight that whole first group, or again, I can control shift down arrow and it'll give it to me. Now notice I can't hit return because then it doesn't like what I did. So I have to then go and hit comma. Now I have to do my second group, which I can do here. Now I'm going to cheat. I don't want that lost 2 in there, so I'm going to just click up here, change that to D2. All right. Now, the next one is asking for tails. We always choose 2 tails in this case. The only time you would use 1 tail is if you had previous knowledge that one group was definitely going to be better than the other, or you would assume that. And from all the studies that we typically do, we don't have that luxury. So we're always going to just put 2 in here. Okay. And now we have our choices. And since this is the same people doing the same things over, that's a dependent t-test, or another name for that is paired, so I'm choosing a 1. All right. And so if I just close that here and hit return, notice that I get this 3.87 e to the negative 45. All right, well, remember in Excel that when you see an e, that's the same as times 10. So basically this is saying I've got a decimal place, 45 zeros, and then 3.87. Well, that's way less than 3.5. So that would tell me, yes, I have a statistical difference. I can be confident that the differences between group 1 here and group 2 is due to the treatment and not just random loss in the people. Okay? All right, the second question that was asked is about diet 1 versus diet 2 at time point 2. Okay, so let's just skim our data here to see if it's all in order. So I've got all my diet 1s together, all my diets 2, and all my diets 3 together. If I'd wanted age groups instead, what I would have done is I would have highlighted the whole data. And so notice now if I wanted just by age group, then I could go to data, and then I'm going to choose sort, and then I would sort by age group. Notice now all the 1s are together, all in the age groups, but not in the diets. All right. I have to make sure I highlight everything. If I don't highlight everything, it only changes that column, and all the other columns stay the same, which then would be bad because then each subject's data would not be matched up with its actual coding over here. Now to go back to what we had before, since I want diet, I'm going to go here, I'm going to go sort, and instead of by age group, I'm going to choose by diet, and I'm going to have it back to where I was. All right, so again, I'm not going to graph this one. We're going to just find the t-test and make an assumption on it. So I'm going to do the same thing. All right, equals t-test. All right, array 1, I'm going to highlight just all the diet 1 people. So I go from 2 to 19. Okay, so that's my array 1 at time point 2. And then I'm going to go down to group 3 where they start, which is right here, and I'm going to highlight all of them. I always choose that my tails are 2. In this case, it's not paired data. There are 2 separate groups, and so I always choose 3 in this case. 3 is the more conservative choice of the 2, and without having to do other tests to see which one would work, that's the one I would choose. That gives me a little more conservative answer. So now when I hit return, it gives me my value here. And again, notice this independent t-test here. 1.94 times e to the negative 19. Well, that again is way less than 0.05. So again, there is a significant difference between these 2 groups, which is what we should have seen with our previous data.